Hello students, great morning to all of you. So in previous class we have discussing about the modern periodic table. In modern periodic table there are total 118 elements. In between them 92 elements are naturally occurring elements. And others are the man-made. Here 78% elements are metallic in character. They are metallic. And remaining are non-metals and metalloids. So today we will discuss about the metals, non-metals and metalloids. What do you mean by the metals? Students, metals are electropositive in character. They are electropositive. What do you mean by electropositive? Means they have tendency to lose the electron. They have tendency to lose the electrons. For example, if I talk about sodium, what is the atomic number of the sodium? It is 11. So here configuration is 281. So students, it has tendency to lose one electron from its outermost shell. Why? Because after losing one electron, it is attaining configuration of noble gas. After losing one electrons, 8 octet is completed. Okay, so it has tendency to lose the electron. After losing the electron, positive charge is attaining on it. So it is electropositive in character. First point, metals are electropositive in nature. Okay, means they have tendency to lose the electrons. Generally, they are solid in state. Generally, they are solid in state. But some exceptions are there. Mercury. Mercury is the metal which exists in liquid state even at room temperature. Generally, all metals are solid in state, but mercury is that metal which exists in liquid state even at room temperature. So this is the exception. They are generally hard. Metals are generally hard. But again exception is here. Exception sodium and potassium. These are the metals which are very soft. Even they can be cut with knife very easily. They can be cut with knife. Metals are malleable. They are malleable. What do you mean by malleable? Means they can be converted into the thin sheets. They can be converted into thin sheets after beaten with a hammer. And this property of metals is known as the malleability. Okay, so metals are malleable in nature. They are ductile in nature. What do you mean by the ductile? Ductile means metals can be drawn into the thin wires. They can be drawn into thin wires. Metal can be converted into the sheets by beaten with hammer. This property is known as the malleability. And metal can be drawn into thin wires. This property of metal is known as the ductility. Okay. Gold metal is highly ductile in nature. You know, from 1 gram of the gold, 1 gram of gold, we can draw 2 kilometer long wire. 2 kilometer long wire. Because they are highly ductile in nature. And because they are more ductile in nature, so they are used for making the jewelry. Metals are sonorous in nature. They are sonorous. Students, what do you mean by sonorous? Sonorous is that property of metals by which they produce sound. They produce sound. What type of sound? They produce ringing sound. When we hit the metal with other metal or with other hard object, then it will produce ringing sound, and that property of metals is known as the sonorous nature of the metals. Metals are the lustrous, means they have luster. What do you mean by luster? Luster means shiny surface. Metals have shiny surface. They get shine. And this property of metals is known as the luster. Okay. Metals are good conductors of of heat and electricity. Students, metals are good conductor of heat, means they allow heat to pass through them. Because they are good conductor of the heat, so they are used for making cooking vessels. Like fry pan, it is made up of the metals like aluminum metal, some other metals. Why? Because metals allow to pass heat through them. So they become hot very easily. So we use metals for making cooking vessels. Because they are good conductor of the electricity. So we use to make electric appliances. Electrical appliances are also made up of the metals. Like electricity is passed through the wires, and wires are made up of the copper and aluminum because they are good conductor of the electricity. Okay, so metals are the good conductor of electricity, so they are used for making electrical appliances, and they are good conductor of the heat, so they are used for making the cooking vessels. Some examples of metals are, tell me about some examples of metal. Gold. Symbol of gold is Ag. Silver, Au. Iron, yes. Oh, by mistake I have written that, beta. Sorry. Symbol of gold is Au and symbol of silver is Ag. Fe, iron. Some other metals also, zinc, copper. Okay, students. We use silver and gold for making jewelry because they are less reactive metals. Because they are less reactive metals. So we use them for making the jewelry. Students, here, elements of group number 1 and 2, they are metallic. They are metallic. Elements of group number 3 to 12, they are also metallic in nature and they are known as transition metals. Except zinc, cadmium, mercury, they are not known as transition element because they have their completely filled d orbital. Transition elements are those elements which have partially filled d orbital. Okay, because zinc, cadmium and mercury, they have completely filled d orbital, so they are not transition element, but they are metals. They are metals and they are soft metals, beta. Zinc, cadmium and mercury, they are soft metal as compared to others. So these show the all properties of the metal, and some exceptions are there in group number 1 and group number 2 because they are the Group number first elements are known as the alkali metals, and group number 2 elements are known as the alkaline earth metals. And elements of the S and P block, S and P block elements combinedly they known as the representative elements. They known as representative elements. Here, this lanthanoid series and actinoid series. All these elements are also metallic in character. And in P block, these elements, which are pink in color, you can see in this table. These are also metallic in character. Means 78% elements are metallic in the character. Okay. So students, these are the properties of metal. First one, metal are electropositive, means they have tendency to lose the electron. Second one is they are generally solid in state. Metals, you have seen a number of the metals in our surrounding like gold, silver, zinc, copper, aluminium, some other metals also. All are solid in state. But mercury is the metal which exists in liquid state even at room temperature. Metals are generally hard, but sodium, potassium, rubidium, some metals are there which are soft and they can be cut with knife very easily. They are malleable in nature. Malleable in nature means they can be converted into the thin sheet by beaten with a hammer. And this property of the metals is known as the malleability. They are ductile in nature, means they show ductility. And what is ductility? Metal can be drawn into the thin wires. Okay, and this property of metal is known as the ductility. Gold is the more ductile in nature. From 1 gram of the gold, we can draw 2 kilometer long wire. They are sonorous. They are sonorous mean they produce ringing sound. When we hit the surface of metal with a hard object, then they produce ringing sound. And that property of metals is known as the sonorous. Then they are lustrous, means they have shiny surface. Metals are good conductor of heat and electricity because they are good conductor of the heat. They allow to pass heat through them. So we use the metal for making the cooking vessels like aluminium metal. Okay, and some metal alloy we use. And metals are good conductor of electricity. So we use the metal for making electrical appliances. Now, some examples of metals are these. Metals have high melting point and boiling point. They have high melting point high melting and boiling point. Because they are hard in nature, they are solid in state. So force of attraction between particle of the metal is strong. So they have high melting and boiling point. Except cesium and gallium. These are the metals which can be melted by heat of our palm. Means if we keep them in our palm, then they get melt. So their melting point is low. These are the exceptions. Otherwise, all metals have high melting point and boiling point. Now students, non-metals. Non-metals are just opposite to the metal. They show the property just opposite to the properties of the metals. Non-metals, they are electronegative. They are electronegative. Why they are electronegative? Because they have tendency to gain the electrons. They have tendency to gain electron. For example, if I talk about chlorine, so what is the atomic number of chlorine? It is 17. What is the configuration for this? 287. Student, after gaining one electron, it can convert into Cl negative. Here 287. If it gain one electron, then its configuration is 288. So after gaining one electron, it attain configuration of a noble gas. It attain configuration of noble gas argon. Okay. So because it is gaining one electron, so negative charge is attained on this. So they are known as the electronegative in character. It is clear to you or not? They are generally soft in nature. Soft in nature. Except diamond. Student, diamond is the allotrope of carbon. It is allotrope of carbon. What do you mean by the allotrope? Allotropes are the compound of same substances which have different physical properties but same chemical properties are known as the allotrope. There are basically three allotropes of the carbon. Main three allotropes of carbons are diamond, graphite and fullerenes. Okay, so these have different physical properties, but their chemical properties are similar. So they are known as the allotropes. Here, diamond is the allotrope of the carbon, but it is the hardest substance of the nature. But it is the hardest substance of nature. So diamond is the exception. It is hardest substance of the nature. They may exist either in solid state or in liquid state or in gaseous state. For example, carbon, it exists in solid state. Like sulfur also exists in solid state. Nitrogen, helium exist in gaseous state. Okay. Then bromine is the only non-metal. Bromine is the only non-metal which exists in liquid state. Which exists in liquid state. Mercury is the only metal which exists in liquid state, and bromine is the only non-metal which exists in liquid state. You will keep in mind. Metals are malleable, but non-metals are not malleable and ductile. They do not show luster. They do not show luster, means they do not have shiny surface. But again, exception is there. Iodine is the non-metal. Iodine is the non-metal which is lustrous in nature. Metals are insulators. They are insulators, means they do not allow to pass heat and electricity through them. But students, graphite, again it is allotrope of carbon, but it is the good conductor of electricity. But it is the good conductor of electricity. And they have low melting point and boiling point. Now next one is the metalloids. Metalloids are those which have property in between metals and non-metals. Metals and non-metals. Their properties exist between the metals and non-metals. Only limited metalloids are there in our periodic table. Elements on this borderline. These are the metalloid in nature. Silicon, germanium, arsenic, antimony, tellurium, these are the metalloids. The elements which lies on this borderline are known as the metalloids. They show some properties of the metals and they show some properties of the non-metals. So they separate, these all are the metals and these all are the non-metals. So in between them, which lie on the borderline, they are known as the metalloids. So students, today we have discussed about the properties of metals, non-metal and metalloids. Have you any doubt in these? Okay, so thank you. Have a nice day.